Okay, good evening, guys. Today I would like to explain how to calculate the Macaulay durations, modified Macaulay durations, as well as the convexity. Before we go to duration and convexity, we also have to know how to calculate the bond. So now we look into one of the example, the ABC bond. We have fixed value of 1,000 and the maturity is 5 years. Therefore, the coupon rate is 8% per annum. The compounding frequency is actually semi-annually. It's make 1 year twice. And you have annual interest rate of 10% per annum as well. So the first step, what should we do? The first, we have to calculate the coupon payment. How do we calculate the coupon payment? Coupon payment is actually coupon rate multiplied by par value and then divided by the frequency, which is n. Therefore, you know that this coupon payment is 0.08 multiplied by 1,000 divided by 2 because it's semi-annually, therefore it's 40. Second, we know that the maturity is 5 years, but it's a semi-annually, so therefore mn multiplied by n 2 multiplied by 5, you have 10 periods. So 10 periods is equal to 5 years, but it's compounded twice per year, so it makes 10. And the third is about the discounted rate or the yield itself. Since the rate is 0.10 per annum, we divide by 2, therefore 0.05. And the fourth step is draw the timeline. So since you know the bond value is a time 0, this is what we need to find. You have year 1, year 2, year 3, year 4, year 5, 6, 7, 8, 9, 10 period. So each of the year we have the annuity payment, which is in terms of a coupon payment 40 from year 1 until the end of maturity, which is the period 10, year 5. As this is a note, a promissory note, therefore the bondholder will receive 1,000 for value at the end of the 10 periods. Since we know the value of the bond is at the year 0 now, the price of today, therefore you write the formula. What is the formula for the bond value? You have the PMP, which is reflect the 40, the annuity, 1 plus I divided by M, power by Mn divided by I by M. So this reflects the annuity. You can see this figure. The formula is actually reflected future present value interest factor annuity A plus for value multiplied by the 1 plus I n by N. As you can see, the second formula is the present value interest factor. So it's combining the annuity as well as the present value interest factor in the payment. Now, step 6. we want to substitute all information into the formula. So the bond value, payment is equal to 40, 1, 1 plus 0.05, then 0.05 plus 1000 multiplied by 1000. So now you can summarize and solve the equations. Therefore, you get 9, 2, 2, 7, 8, 2, 6, 5, 0, 7. So this is the bond value. So this bond value will be useful for the Macaulay iterations as well as convexity. 7. We want to explain about the Macaulay iterations. You can see the summations equal to 1, meaning you have to calculate the cash flow one by one and discounted it and multiply by the periods. So in this case, we want to calculate 40 discounted to year 0 and multiply by the period 1. 40 discounted to year 0 and multiply by period 2. Then after you get all the data until maturity, you sum all the present value of cash flow and divide it by the bond value itself. Now let's look through the first calculations for the cash flow first. So the 0, what is the PV? What is the cash flow? The cash flow is 40, but you have to discount. So when you discount 1 plus 0.05, how many years to year 0? N equal to 1. So 1. Then we multiply by 1 times the period. So now you get 38.095, which is equivalent to 38.10. So this is the cash flow from year 1 to year 0. You have to repeat the process until year 10. So in this case, after you completed the calculations of present value of the cash flow, basically you will get total present value of cash flow around 771,408. Now we want to look into the formula of convexity. When you look into the convexity, we can break into three major formula, which is 1, 2, and the present value of the cash flow. So the first, how do we start? 1 plus 1, 0.05 by 2. So you will get 0.907 029. So you use at 0.90703. And then we look into T, the cash flow because T powered by 2 plus T, this means the timeline 1 power 2 which is equal to 1 plus 1 equal to 2. Then the period 2, 2 power by 2 plus 2 equal to 6. And period 3 is become 3 power by 3, 3 power by 2 which is equal to 9 plus 3 which is equal to 12. So it will continuously up to the period of 10. So therefore T2 plus T, this is for the cash flow 1, 1 power 2 plus 1 equal to 2, cash flow 2, 2. So you will do until cash flow 10, which is 10 by 10 plus 10, which is equal to 100 plus 10, 110. So now let's put all together in the tabulations in the Excel worksheet. So now you can see my Excel worksheet. So you can see the period 1, 2, 3 until 10. Then you have two cash flow. The first one, the last coupon payment, and the last is the par value. Now you can see the cash flow, which is we already draw in the timeline for T until at the end of the period, gathered with 1000 par value. Here are the we call as present value interest factor because it is semi-annually 5%. So how do you calculate? For 1 divide 1 plus 0.05 powered by n. So since here is at year 1, so 1 divide 1 plus 0.05 powered by 1, you get 0.9523809584. So you can use up to 4 decimal point, which is 0.9524. So how about the present value interest factor of interest rate 5% to the second period? So you repeat the process, 1 divide 1 plus 0.05 plus year 2 to year 0 is 2 n equal to 2 period. So therefore, you can see that the present value interest factor is around 0.907029. So you can use in decimal point at least 4. So therefore 0.9070. So now, how do you calculate the PV of the cash flow? Because all of this cash flow must be discounted. equal 0. Therefore, the cash flow multiplied by the present value interest factor at 5% per period, you get the cash flow of 38.0952. How do you calculate the duration? We calculate the durations by PV of cash flow multiplied by T. So therefore you can see the first cash flow in PV 38.0952 multiplied by 1 to get the durations of 38.0953. Where else you can see how to calculate the durations year 2. You get the PV of year 2 36.21 2812 multiplied by 2 at 72.5624. So this is how it's calculated for duration. Therefore, you calculate until at the end of a period, which is include the coupon payment and the par value. Or else you might want to combine as well. It's acceptable method if you want to combine. Therefore, you can see the durations here is 7.408, and here you can see 922.78 is actually the bond value. So now we want to calculate the regulations for the convexity. As I mentioned, we will give three different components in order for us to calculate the convexity. T power by 2 plus T, 1 power by 2 plus 1 equal to 2, 2 power by 2 plus 2, 4 plus 2, 6. So 3 power by 2 plus 3, 4 power by 2 plus 4. And you have to do continuously until a period of 10. Now we want to look into the second component, 1 divided by 1 plus I divided by n. Therefore, it will be constant value until the end of period. So since the I per n is 10 divided by 2, therefore 1 plus 0.05 power 2. So you will get the same value until at the end of the period. Now we look into the convexity. As I mentioned, the convexity is actually the combinations of the present value, the time weightage, and the discounting. Now we look to the data 38.0952 multiplied by 2 multiplied by the discounted rate 0.9070 to get the convexity for the one of 69.1070. The same process you repeat until at the end of the period. So let's look into the second cash flow. 362812 multiplied by 6 multiplied by 0.9070, we get 197.4486. So now we get the convexity in ringgit value every cash flow in the interval. Therefore, you need to add up from the first until 10. After you add up until 10, this is the summations of the convexity, and this is the summations of duration. How do you calculate Macaulay duration? You will calculate the Macaulay durations by using the durations, the value of ringgit duration 7714.08 You divide by the bond value, which is 9 to 2.78. Therefore, you divide by 2. You get 4.1798. So this is called the duration, or another name we call as Macaulay durations. The second calculations you want to know is the modified durations. How do you calculate the modified durations? The Macaulay durations divided by the 1 plus 0.05. So 4.1798 divided by 1.05, you get the modified durations of 3.9808. So far, it's quite easy to answer the modified durations as well as the Macaulay durations. Now we go for the last calculation for convexity. So you already have the total of convexity. So therefore, the total of convexity 72248.57 divided by the bond value you get 78.29, and you divide it by the frequency by 2. Therefore, you get 195736. So that's all, guys, for the calculations for durations, modified durations, as well as convexity. I hope that this video will help you for your understanding and to answer the questions. Have a nice day, good night, and we see you again in the next video. Thank you.